Beautiful. So how about we start dissecting the whole algorithm, the whole idea of raycasting, and let's have a very high-level view of what this technique is all about. We start with this very basic 2D idea of our world, right? And when I say 2D idea of our scene, we are going to have a map, right? So we're going to start to looking at this 2D idea of a map. And in our map, we're going to have these obstacles, what I call the walls, right? So the walls of my map is going to be this little container that we're going to have my player. Do you see the magenta there? My player is going to be navigating and moving around and changing the orientation and moving around the map. So these two basic ideas of having a player moving around the map and the walls of my map, these are going to be the fundamental ideas behind the raycasting algorithm. And together with my player, you know that my player is going to have a direction where we are looking at, right? So, and that direction also comes with the idea of having a field of view angle. And you will hear me talk about this field of view a lot throughout the course, right? This idea of having an angle of opening is very important for us. Do you agree that based on that field of view, I am going to start casting and shooting rays? So in my technique, in my algorithm, I'm going to start from left to right. Right? So I'm going to start from left to right, and I'm going to fill my field of view with all these rays that I'm going to cast. I'm going to cast, I'm going to shoot all these rays, and what I am really interested in is the distance. So how long it took for the ray to leave the player and hit a wall. So I'm interested in the collision with a wall, right? So the distance of that ray is going to give me the distance between the player and the wall. And this is a crucial part. Do you agree that in physics, things that are closer to me, they appear bigger, and things that are further away from me, right, far away, they appear smaller? That is what we're going to use for this idea of a projection, right? So we're going to get this very basic 3D fake projection, right? I am exaggerating here the thickness of each pixel column, right? But so we really understand what this technique is all about. For each one of the rays that I'm casting, I'm going to have one strip of pixels, right? One column of pixels that I'm going to render. The height of that column of pixels depends on the distance of the wall. So if I shoot a ray and that ray hits the wall really fast, that means that that wall is very close to me. That means that I'm going to have a very tall column of pixels, right? So this thing right here is very close to my player, should be rendered very tall. If those rays take a long time to hit the wall, it means the wall is very far away from me, meaning that I'm going to have to render things shorter. So that is why these walls right here are shorter in size. The further away that wall is, the shorter I'm going to render that column of pixels. The closer the wall is to me, the taller I'm going to render that wall of pixels. It doesn't seem like a complex technique, but if you put everything together, if you do that for pixel by pixel column that you have in your screen, and if you render all those pixel columns one after the other in an animation loop, you get this smooth animation effect, right? In real time, you tell the computer to perform things as fast as it can, and the computer will render all these things and will give us this fake idea of animation, this fake idea of projection in real time going on the screen, right? This is the basics of what raycasting is all about. So just again, to put things into context, right? Remember the Wolfenstein 3D. So if I have my player looking at my wall, I'm going to start shooting one ray. So I'm going to start from left to right. I shoot my first ray, I get that distance, I see how far that wall is from me, and then I render one column of pixels. Right? Let's just say that that wall, it took a very short time, and then we just hit the wall, we got the little distance of the ray, the wall is very close to me, I go and I render a little column of pixels in that size. And then I move a little bit to the right? I go to my next ray, I cast my ray, I look how far it took, I render my wall. And I'm going to do that with all the rays. Do you see? Ray by ray, depending on how far the wall is, depending on how long it took for the ray to hit the wall, I'm going to have different sizes of those column strips. So do you see? The walls are being cast right there. I have all these ideas of rendering my wall. And of course, if I stop and analyze just one strip of pixels, right? So if I just look at one column of pixels right there, what we can get is the height of the little rectangle strip, right? The height of that column of pixels depends on the ray distance to the collision of the wall, right? So what is the ray distance? I get a calculation that is going to tell me the height of this little strip of pixels that I have. That is it, right? And you will see that that is not only it, right? So if you look at this example right here, something else that you'll see programmers do, and I think we will do that, is the color or even the brightness of the little rectangle strip also depends on the ray distance. So do you see how in this example right here, the walls that are further away from me, they have this darker color, and the wall strips that are very close to me, they are very bright, very white color. That also gives us this idea of depth, right? It's almost like this fake lighting effect. So you will see programmers also do that. Not only the height of the walls, I can only change the shading of the walls depending on the distance of the thing. That gives us also a good effect, right? So how close things are with me, the brighter they are. The further away, the darker they are. To give this idea of lighting, right? Bouncing off the walls and how darker they are. That is also a useful technique. And this is what we're going to try to achieve, right? We're going to implement, we're going to code our raycasting, and we're going to try to see these things in real time on the screen.